Hi students, welcome to virtual class of Municipal Corporation of Greater Mumbai. I am Sreekumar. The class is for 8th standard students. Subject is mathematics. Let me begin the class. Dear students, we are entering into a new chapter, surface area and volume. In the previous lesson, you learned about the formula to find out the area of certain regular figures like square, rectangle, circle, trapezium, parallelogram, triangles of different types, etc. In fact, this is a continuation of the same chapter, so you should be thorough with the previous chapter in order to thoroughly understand the content of this chapter. Area is known to you, and the formula to find out the area of common regular figures are known to you. This chapter is talking about surface area and volume. What is the difference between surface area and volume? That you should understand first. Surface is having a meaning just like table surface, surface of the desk, surface of the wall of your classroom, the floor surface. You are familiar with the word surface, and area is a mathematical approach to it to find out how much is the surface. So that is the first part of this particular lesson. And second part is volume. Volume will be talking about, if you are thinking about the surface, when you think about the surface on which you are sitting, how much space you are taking, not only in the surface but also in the air. That means if you're keeping your own school bag on the top of your study table, naturally on the surface the school bag will be taking some area, which you know very much now, and in the air also it will be taking some space. When both these together comes, it becomes volume. This is a basic concept of volume. You will understand about the mathematical approach to the volume of regular figures, especially what happens to the concept of a cylinder. In the case of a cube, in the case of a cuboid, you will understand in this chapter. So let me go ahead. This figure is very much known to you. This is the figure of a cube. Consider this cube as a glass cube. That means it is transparent, not a colored one. Pure glass cube it is. And the cube is having a peculiarity that it has got all its 6 faces are squares, right? Each side is each face is a square. And we know that if the concept of surface area to be explained with the help of this particular cube, surface is that which is in contact with air, or which can be in contact with air. In the case of this particular figure, which we name as cube, I would say is a 3-dimensional presentation of a square extended in such a way that it gets 6 faces. So if I number this, one which is in front of you, it is 1, and one which is behind as 2, on my right as 3, on my left as 4, and the top as 5, and the bottom as 6, you can identify 6 faces. And each face is a cube, is a square, as I told, and the area of a square, which you very thoroughly studied, is calculated by side square, or if I name the side of this particular square as L centimeter or simply L units, I will write L square. So in order to get total surface area of this cube, I should add the 6 faces, or I should write 6 into L square, 6 L square. L stands for the length of the side of the cube. Sometime it will be find out the area of only the lateral surface, only the top surface, only the bottom surface, or except bottom surface, except top surface. All these are different situations, but basically you should know that we can calculate the total surface area of a cube with the help of formula 6L square. An introduction of this formula and application of this formula you have done last year. So let me go ahead with another recalling. What is it? This is a cuboid. What is the difference between a cube and a cuboid? Cube is having all its edges, all its faces same. But in the case of a cuboid, it is a three-dimensional expansion of a rectangle, I would say. And in that case, it has got, a rectangle has got its own length. If you look at the front face of this, its own length, which we earlier named as length, then it has got its breadth, and here this is also length, this is also length. For such length you can see, or for such edges are there. Then you are having its own breadth over here, breadth over here, breadth over, all depends upon how you look at it, because it is three-dimensional. Then if I say this is the basic, I can say this as height of it, correct? There are 4 height on which this particular cuboid is made of. If we think about the same concept of surface area in the case of a cuboid, we know that there are different faces. There are 6 faces for this cuboid also. That way it is similar to a cube. But all 6 faces are not alike. If I think, or if I take the front and back, I will say that here is a length and a height. Back also there is a length and a height. If I take the right side of me, there is a breadth and a height for this particular side. Here also breadth and a height. If I think of top and bottom, considering this as top, so there is a length into breadth here, length into breadth here. That way there are 3 sets of faces here. So we know that we should 3 sets or 3 pairs are, thereby it becomes 6 faces. So we developed a formula last year itself. Length into breadth will be there 2 times, and length into breadth will be there 2 times, breadth into height will be there 2 times, and as well as length into height also will be there. So we developed a formula 2 into common, length into breadth plus breadth into height into length plus length into height as the formula for calculating the total surface area, which I can write TSA now in the case of a cuboid. Another thing you should recollect at this moment, whenever we talk about area, it will be square centimeter or meter or kilometer depending upon the unit given. It can be written as centimeter square like this, or you can literally write it as square centimeter. These are the 2 ways of presenting it. That concept of surface area we need to extend to the next concept, which we are going to learn about, the concept of volume. So surface area talks about area only, considering all the surfaces of the given figure or given object. As the object is of regular shape, these are something mathematical approach. In front of us there are different structures, different things around us, but are not having any regular figure, anything you can see around you. We will come to that later in higher classes, but regarding regular figure, we have the concept that surface area can be calculated by totaling the area of different faces of the given figure. Okay, let us go ahead. When we think about volume of the same cube, yes, I told you volume is a different concept. Where the cube is placed on the surface of a table, we can suppose I mark it here, this is the bottom. A square area is used by the cube to remain on the table, but it has got a height, this 4 I mark as height, which it occupies in the air. So when we think about volume, we consider this also. So if I consider this as height, this can be considered as depth, which is away from you, towards or away from you. If I write a depth over here, so base is there, height is there, depth is there. For a three-dimensional figure it is. And how much space it consumes, that is what is explained in the case of volume. We can calculate it by using the same units. We will say it in this much breadth, this much length, and this much height it will consume. So 3 times the unit will come. If this is a cuboid, here also we know that the cuboid has got its length here, its breadth here, or which we can say as depth now, and height over here. So how can we calculate the volume in such cases? Consider this particular cube is having a size of its side as 1 centimeter, or this will be 1 centimeter, suppose. In that case, we will say that it will take 1 centimeter length, 1 centimeter breadth, depth, and 1 centimeter height. So 3 times if we say, it will take 1 into 1 into 1, we should say, right? Like that, if you think of divide this into 1 centimeter length, suppose that there is 3 centimeter over here, and this is equal to 1 centimeter, and this is equal to 2 centimeter, I mean the height we can consider, then what we will say, 3 into 2 into 1. This much of space it occupies, and this is the way by which we calculate the volume of a cube and cuboid respectively. So in the case of a cube, we will be forced to write the volume of a cube can be calculated by multiplying length into breadth into height of that cube. But in the case of a cube, all are equal, so we will write L cube, or side to the power of 3. And in the case of a cuboid, volume of a cuboid, we will write length into breadth into height, because there is a very possibility that these 3 will be different. At least 2 will be always different. Otherwise it will become a cube again. So in that case, we, through activity or practically observing or practically thinking, how can we include the space occupied by this particular figure? How can we accommodate that? How can we include that in our concept of occupying space? We developed the concept of volume and developed the formula for calculating volume of basic figures and structures like cube and cuboid. Once if you understood the concept of volume from cube and cuboid, you can understand the concept of volume of anything around you. The remote which is used by you every time at your home, operating the electronic gadgets, it occupies a space. It may have a cuboid shape. Regarding a bottle of water, when kept on the table, it occupies a space, but it is not a cuboid. It is something cylindrical. We will come to that. Understood? So this is the concept of volume for you at this moment, and you should understand that as far as cube is concerned, it is L cube. As far as cuboid is concerned, it is length into breadth into height. I will continue with a little more explanation given in the textbook and activity. This is a cube. If I keep on adding the cube, so we know that I added 3 cubes kept in a particular manner, 3 centimeter length and 1 centimeter height and 1 centimeter depth. Now if I add further, it becomes different. Now see, look at it. Now I have added another set of 3. What happened is the height became 2 centimeter, the length became 3 centimeter, remains as 3, and the depth is 1 centimeter. So we are, by adding, we are occupying more space, or we are adding more space by which this particular cuboid is using. Now it is a cuboid because the length is there, breadth and height, 3 factors are coming. Right? I can rearrange these cubes in different ways. So it's a glassy piece of cube I said. See, if I arrange the cube in this manner, the same number of 6 cubes I kept in this way. Here the height became 1 centimeter, the depth or breadth became 2 centimeter, the length became 3 centimeter. So it occupies a different space sometime. Anyway, it includes a concept of 3-dimensional. If I figure out what is the exact structure of this, if I figure out means if I convert, these are pieces now, pieces of 6 pieces of cube. If I convert that into a real cuboid, it may look like this. Is it not? And I will write the length over here as 3 centimeter, breadth over here as 1 centimeter, height over here as 2 centimeter. I derived it from here. Understood? If I try to convert this into a regular cuboid figure, I will write over here as 3 centimeter. Understood? So this is 1 centimeter, this will be 2 centimeter. And I will calculate the volume according to the formula length into breadth into height. So my dear students, this is a simple concept but having high application in the coming classes, because you will be learning about solid figures furthermore in higher classes. Okay, let us try to attempt a real situation where it is given that the length and height of a cuboidal warehouse is 6 meter, 4 meter and 4 meter respectively. How many cube shaped boxes of size, not side, size 40 centimeter will fill the warehouse completely? Before proceeding, I would like to tell another important thing related to while doing the sums related to this kind of situation. A rough diagram is always good. Second, you need to check the unit. Here it is meter, here it is meter, here it is meter, here it is centimeter. As always, we cannot deal with the different units. Either you can convert this into centimeter or centimeter into meter. In this case, I would prefer to convert meter into centimeter, because if you convert 40 centimeter into meter, you will divide it with 100 and you will be writing 0.4 meter. So we will avoid decimal number by multiplying the meter or changing the unit meter into centimeter. And we are asked to find out how many cube shaped boxes of size 40 centimeter can be. Suppose this is a warehouse. You may wonder that a warehouse looks like a cuboid. It is given, and it is also given that the length, height of a warehouse, that means the length is given, height is given, breadth is also same. All three are given. So let me mark the length as 6 meter here, and the breadth as 4 meter, and the height also 4 meter. And we are asked to find out how many cube box of size 40. So we need to find out the volume of the warehouse, and we are going to put these small cube shaped boxes inside. We have to keep it like this, small boxes. How many such boxes can be kept? For that, in a larger volume, a volume of the warehouse, how many such small volume can be occupied? So we need to find out the volume of the warehouse and volume of the cube, and find out volume of the small boxes and find out the number. So there are 3 stages for the problem to solve. First phase is find the volume of warehouse. That we will do. Then we have to find the volume of each a small box. If we, after getting both these, we can go for finding out the number of boxes that can be kept inside that warehouse. Warehouse is having a meaning that some storing is done, and warehouse is an area, place where we store food grain, sometimes spare parts, sometimes any item can be stored. So here it is in boxes, something which can be contained in the box is stored in the warehouse. Now we are thinking about the mathematics behind it. The step 1 will be such that we will find out the volume of the warehouse, right? Find the volume of warehouse. So it is given that length of warehouse is equal to 6 meter. As I told you, I am converting it into 600 centimeter. Breadth is given as and as well as height is given as 4 meter, which is equal to 400 centimeter. The volume can be calculated by the formula length into breadth into height, where we will be simply multiplying 600 into 400 into 400. Okay, so after multiplying, you will be getting an answer for this. We are not calculating it now because we have to divide it with the volume of the box. So we will save the time by keeping it like this. Step 2 is to calculate the volume of the box. Volume of the box. The box is a cube shaped, only all sides are equal, is equal to. So where we will be applying the formula L cube, and L is equal to 40 centimeter, and L cube will be equal to 40 to the power of 3. Now the step 3 is dividing the volume of the warehouse with the volume of each box. So that is a step 3 to find out the number. So what we will write, number of boxes, that is what is that can be kept inside, is equal to volume of the warehouse divided by volume of a box. We have not calculated, but we will put it here. Volume of the warehouse is nothing but 600 into 400 into 400. And that of a box is equal to 40 cube, means 40 into 40 into 40. Now you can solve it. On solving, you will be cancelling the zeros. You will be dividing it 1 time, 10 times, right? And this will be 1 4 24 150, and you will be getting the answer 1500 boxes can be, because you are getting the number kept inside. So we solved a sum containing the concept of volume and application of the formula of cuboid, my dear students. So this way we will be applying the formula of cuboid in a situation. The question is an example from your textbook, and I directly copied it. There is a small error in its presentation. The length and height of a cuboidal warehouse is given. They forgot to mention about the breadth, but we could understand it from the data that are same, but we will be adding that over a length, breadth and height. Okay, so the question is clear, and as well as answer is obtained. You will go through this once again, not a big thing. Learning the formula and applying it in different situations is the most important thing.
Now click on the subscription button below to subscribe the channel, then the bell button to get the notifications of the new videos. Thank you.